Dear students, let us continue our discussion on quantum mechanics. And today basically I will discuss about Schrodinger equation. And there is time dependent Schrodinger equation as well as time independent Schrodinger equation. So what we have studied in the fifth postulates of quantum mechanics, that was basically IH cross del psi, which is a function of position and time upon dt, equal to H psi. And H is the Hamiltonian operator, and here you know I is just square root of minus 1, that is complex number, and H cross is H upon 2 pi, and psi is a state of a system which is depend on R and T. So this we have already defined in postulates number 5. If you are new in this channel, then see the playlist. You can see where I have discussed different postulates of quantum mechanics. In the last postulates, that is in fifth postulate, I discussed about this equation. Let us first tell you what is the H cap. That means the Hamiltonian operator. What is the form of the Hamiltonian operator? Basically, the Hamiltonian operator है, that is basically the sum total of kinetic energy and potential energy. So equation, if you say kinetic energy operator plus potential energy operator, this is the total energy operator. Now what is the kinetic energy operator? So kinetic energy को हम ऐसे in terms of position momentum लिख सकते हैं, that is P cap square upon 2m, and potential जो है that is maybe function of position and time V r comma t. Now what is P cap? What is the momentum operator? We have P cap, okay, so that is basically minus IH cross del operator. Now if you square this, you will get P cap square, that is I square H square, that is again minus 1, so it will be minus H square del square. So now if you put here, you will get Hamiltonian operator H cap, that is basically minus H cross square upon twice m into del square, and there is V r comma t. But most of the cases we have seen potential energy is only function of r. So if potential energy is only function of r, then we can write this is simply V of r. So now let us put this H cap here, so you will get the form of this equation in different form. So it will be in that case IH cross del psi, which is function of position and time, upon del t equal to minus H cross square upon 2m into del square psi. This psi is also obviously function of position and time, okay, and plus V of r into psi of rt, okay. So this is now let us rearrange this equation in this way. IH cross del psi upon del t equal to minus H cross square upon twice m del square psi rt plus V of r into psi rt, okay. So this is the equation. Now let us use the separation of variables. Let us take psi as a function of r and t, and let us use this psi rt is basically function of r and function of t separately. Now if you put this here, what you will get? This will become IH cross, and if you take the differentiation of this function del psi upon del t, so that will be phi of r, which is not function of time, and it will be del f upon del t. So that will be equal to minus H cross square upon twice m. Okay, again here we have del square psi rt, but del will operate only on function of r, so f of t will be outside here. So f of t, you can write f of t or simply f, does not matter, but you have to remember that this is a function of time, okay. So f of t, and you have phi and del square of phi हो जाएगा, so it will be del square phi, which is also function of r, and then usually plus v as a function of r, and if we talk about psi, then this is phi of r and f of t, phi of r and f of t, okay. Now what you have to do, you have to divide the equation by phi of r into f of t. Okay, so if you divide, then here you will get only I h cross into 1 upon f of t into del f of t upon del t. Here you will get minus h cross square upon 2m into, if you divide this equation by phi of r into f of t, so f of t will be cancelled out, so it will be just 1 by phi of r into del square phi of r. Okay, plus you will get v of r. Okay, so you can see the function of times are in the left hand side and function of r in the right hand side, so the variables are separated now. So now let us take this are equal to e a constant. Okay, now you will get two equations. If you equate this and this, you will get one equation, and from here you will get another equation. So now what you will get here, if you write this equal to e, so you will get just minus h cross square upon twice m into del square phi of r. Let us multiply with phi of r, so del square phi of r plus v of r into phi of r equal to e phi, which is also function of r. And let me write only phi. Okay, don't need to write phi of r because we have already defined phi as a function of r. So now if you rearrange this equation again, what you will get, you will get minus h cross square upon 2m into del square phi plus v phi equal to e phi. Okay, now if you multiply with minus h cross upon 2m, if you multiply twice m upon h cross square minus, so what will be here, del square phi minus twice m upon h cross square into v phi equal to minus twice m upon h cross square into e phi. Okay, if you multiply with minus twice m upon h cross square, so here it will be 1, here will be minus, here will be minus. So del square phi, you can see if you take this left hand side, so it will be just twice m upon h cross square into e minus v into phi. Okay, equal to 0. So let us write these two together. Okay, which is nothing but only function of r, which is time independent equation. So this is called basically time independent Schrodinger equation. So this is basically called time independent Schrodinger equation. Now there is another equation which have the form, that is I h cross into 1 upon f into del f upon del t is equal to e. Now from here you can write this is nothing but del f upon f is equal to e into delta t, but if you take here this I h cross in the right hand side, it will be 1 by I h cross. So if you multiply with I, you can write this is minus I upon h cross into e into delta t, and this is del f upon f. Now if you integrate this equation, you will get from here that is ln f equal to minus I e t upon h cross. Okay, and if you take another constant here, suppose plus ln c. Okay, so what you will get, you will get f equal to c e to the power minus I e t upon h cross. Okay, so this is your solution है. This solution is from the time dependent part. Okay, so you have two solutions, you will get phi from here and we have f from here. So what you can write finally, the equation was, the main equation was where we have used separation of variable, that was psi r comma t, that was equal to phi r into f of t. Now if you take this constant consumed here, so it will be just psi r comma t equal to phi of r into e to the power minus I e t upon h cross. So this is your final psi. Now what will be phi of r? That will depend from this equation, which will depend on this potential function also. Okay, and you can see this solution is basically stationary state, because you have psi of r is this, and if you find out psi star, that means the complex conjugate of this, that will be phi star of r into e to the power plus IET upon h cross. Now if you take psi star, that is the probability density, then you can get phi star, because this part will be 1 after multiplication. So you can see there is no time part. Okay, so this is not depend on time, only on space. So that's why the probability is stationary, and that's why this solution is also called stationary solution. But in general, this is not stationary solution, because in general there are different eigenvalue and for different eigenfunction. So there may or may not be stationary wave function in general, but for this particular solution you can say this is a stationary solution. Okay, so this is how we can discuss the this was the Schrodinger equation, and from the next class we will discuss about various types of application of Schrodinger equation. And before that we have one topic also, that is called conservation of probability, that we will discuss in the next class. Okay, so for today, thank you. And if you are new in this channel, and if you think that the videos are helpful for you, then subscribe this channel. Okay, thank you.